Hello, welcome to my presentation video on the effects of harmonics on capacitors. My name is Martin Lavachka, and in this video I will talk about the resonance, its effects on capacitors, and possible solutions to manage harmonics in the network where the capacitor bank is installed. Capacitors are linear reactive devices and, consequently, do not generate harmonics. Capacitors are especially sensitive to harmonic components of the supply voltage because the capacitive reactance decreases as the frequency increases. In practice, this means that a relative small percentage of harmonic voltage can cause a significant current to flow in the capacitor circuit. Resonance is created by very high or very low impedance values at the busbar level at different frequencies. These impedance variations modify the current and voltage in the distribution network. When the natural frequency of the capacitor system inductance combination is close to a particular harmonic, a partial resonance will occur. The corresponding frequency is called the resonance frequency of the circuit. At that frequency, the impedance is maximum, resulting in significant voltage distortion. The voltage distortion at the bus level results from the two different factors: the connection of nonlinear loads that generate harmonic currents and the voltage distortion present in the supply network due to nonlinear loads outside the considered circuit. A significant indicator of harmonic importance is the ratio of nonlinear loads in the supply network. Major voltage distortion is present at the busbar level due to the resonance frequency of the circuit. The voltage distortion is accompanied in the LS plus C circuit by the circulation of harmonic currents greater than those consumed by the loads. The increased current flowing through power factor correction capacitors will cause overheating of the capacitor, with degradation of the dielectric, which may result in its eventual failure. Standard capacitors are designed for an RMS value of current equal to 1.3 times the rated current rating. Standard capacitors can be used if the percentage of nonlinear loads is less than 10%. One of the possible solutions is the connection of capacitors with higher current ratings that can be used to increase the safety margin. The technology of these capacitors allows an overcurrent higher than that strictly required by the standards. Capacitors with improved current ratings can be used if the percentage of nonlinear loads is less than 20%. Another possible solution is the connection of power factor correction capacitors with detuned reactors. To avoid resonances, detuned reactors must be installed in series with the capacitors. Installing detuned reactors in capacitor banks increases the impedance of the reactor-capacitor combination for higher order harmonics. It is called a detuned reactor because the capacitors and reactor are configured in a resonant circuit configuration not tuned to the frequency of any harmonic order. The tuning frequency can be expressed by the relative impedance of the reactor, by the tuning order, or directly in Hertz. The most common values of relative impedance are 5.7%, 7%, and 14%, which are used with high levels of third harmonic voltages. A system can be composed of several reactors to eliminate various harmonic orders. The presence of the reactor increases the fundamental frequency voltage across the capacitor. This characteristic is taken into account by using capacitors that are designed with a nominal voltage higher than the series voltage of the network, as showing in the following table. Let's talk in detail about capacitor technology. Low voltage technology capacitors are dry type units composed of a self-healing metallized polypropylene film in the form of a two-film roll. Self-healing is a process by which the capacitor restores itself in the event of a failure in the dielectric, which may occur during high overloads, voltage transients, etc. When the insulation breaks down, a short-lived arc is formed, as you can see in the image above. The intense heat generated by this arc causes the metallization in the vicinity of the arc to vaporize. Simultaneously, it reinsulates the electrodes and maintains the operation and integrity of the capacitor. Capacitors must be associated with overall protection devices to limit the consequences of overcurrents. In addition to external protection devices, the capacitors are protected by a pressure-sensitive disconnector which shuts down the capacitors if an internal fault occurs. This allows for safe disconnection and electrical isolation at the end of the capacitor's life. The pressure-sensitive disconnector works as follows. Sometimes higher than normal current levels occur, but insufficient to activate overcurrent protection. These failures are resolved through self-healing. If the leakage current persists and self-healing repeats, the defect can produce gas by vaporizing the metallization at the defect location. This will gradually increase the pressure inside the container. The pressure can only cause vertical expansion by bending the lid outward. The connection wires break at the intended point and the capacitor is irreversibly disconnected. On this slide, you can see the main electrical characteristics of LV capacitors according to IEC standards. We come to the end of this presentation. Now you know everything about the effects of harmonics on capacitors. Thanks for watching.